Alright, here are a couple more functions where we're going to try to figure out if they're inverses or not, and like the other video, keep in mind that inverse functions undo each other. So if I put something in as x into one of the functions and I take that result and put that into the other function, the effects should all be undone and I should get just the x back out again. And here's how we test it out. Let's start with, does f of g of x equal x? So I'm going to take f of x, and that's equal to 3x plus 8, and then I will calculate f of g of x. So for everywhere I see an x, I'm going to put in g of x, and that would be 3 times x minus 8 over 3, and bring down the plus 8, and that gives me 3's cancel out, x minus 8 plus 8, and that equals x. So that one worked out fine. And then we want to see g of f of x, does that equal x? Start with g of x, which is x minus 8 over 3. And then we want g of f of x. So everywhere I see an x, I'm going to put f of x instead, which would be 3x plus 8. Then minus 8. Bring down them over 3. And that's equal to 8's cancel out, so I get 3x over 3, and that equals x. That one checks out too. So that means that yes, f and g are inverses. And you can also do just like a quick little number check just to kind of make sense of what's happening with numbers instead of seeing it all done algebraically. If you put in x is equal to 1, then you get 3 times 1 is 3 plus 8 is 11. If you take that 11 and you put it in as an input for g of x now, the effects should be undone and we should get the 1 back again. So if I put in 11 now, I get 11 minus 8 over 3, which is 3 over 3, equals 1. So you can kind of play around with numbers just to really get a feel for what's happening with the inverse functions. But to really determine if two functions are inverses, you want to do out this algebraic verification that you do get x back again in both cases. Alright, let's do one more problem. F of x is negative x and g of x is negative x. Alright, so thinking about that with numbers, if I put in x is 2, I'm going to get a negative 2 here. If I take that negative 2 and put it in for x here, negative negative 2 is going to be 2 again. So it looks like they're going to undo each other, and let's prove it out algebraically. Start with f of x. F of x is negative x. For now, put in g of x as the input. F of g of x is equal to, and I keep the negative, bring down the negative sign, replace x by whatever g of x is. G of x is negative x. And that gives me negative negative is plus x. So that one worked out. And the other one, we start with g of x instead. G of x is negative x. And we want to find out what happens when we put f of x as the input. And do we get undone effects and just get x out again? So I have negative times x. I'm replacing x by f of x. F of x is negative x. So I get x. And that worked out too. That means f and g are inverses.